In this unit, we're going to look at exponential functions. In this lesson, we're going to review the exponent laws.
Right. Hi, everybody. So in this section here, in this series of videos here, we're going to look at exponential functions. But before we get to that, in our first lesson here, we're just going to review the exponent laws. These are things that you should be familiar with from probably previous courses here. We just want to make sure that we're all on the same page as we move forward with this here. And it's going to lay the foundation for the work that we do with the exponential functions in some later videos here. So first of all, one of the first laws of exponents that students learn here is the multiplication law, which basically says if you've got two powers that are multiplied together and their bases are the same, and that's key here. So I've got x to the m multiplied by x to the n, that the product is going to be a power with, again, the same base, and the exponent that we get as a result is going to be the sum of the two exponents, okay? So we simply add the exponents together. And it's important to say that at the end here, it says when the bases are the same, we add the exponents, and the base stays the same. There is a mistake that typically gets made here, and we'll talk about that in just a moment here, but let's take a look at some of these examples. So first of all, we've got x cubed multiplied by x squared. Okay, so I got two powers multiplied together. The bases are the same, so this is going to be x to the sum of those two exponents. And so x to the 5. With this next one here, and this is where the confusion could pop up here. I've got, again, two powers, 3 to the a multiplied by 3 to the b. The bases are the same. See, it is very tempting for people to want to do this, say, well, I'm going to multiply the two bases together and then add the exponents. But that is not the rule. That is not how the rule works here, okay? Notice that, like in the first question here, it didn't become x squared to the 5th, okay? The multiplication of those two powers gets done when we add the exponents. So 3 to the a multiplied by 3 to the b is going to be 3 to the, well, I don't know what a and b are, but I know that I am going to add them together. So it's going to be 3 to the a plus b. This next one here, really the whole purpose of this one here is just to give us a moment here to say that, look, if you've got a power there and you don't know what the exponent is, it's a 1, right? We won't write it, but that's typically what it's going to be there, or typically that's what it is when it's not written. So this is going to be s to the 5 plus 1, okay, or s to the 6th. But we typically won't write that 1. I'm just going to leave it like that. And then over here, this last one here is basically just to point out that, you know what, it doesn't really matter if you've got negatives in there, integers. The bases are the same. So my product here is going to have a base of x, and it's going to be to the power of 4 plus negative 2. Now, 4 plus negative 2 is going to be 2, so the answer here is going to be x squared. Okay, and that's the multiplication law. Now we want to take a look at the division law. Okay, and again, you're probably quite familiar with the division law here. That simply says if you're taking two powers with the same base and you're dividing them, and whether that's written horizontally or vertically here, the result is going to be that a power with the same base, but it's going to be the difference in those exponents there. Okay, we're going to subtract the exponents. So in our examples here, I've got x to the 5th divided by x squared. That is going to be x. I get a power of x to the 5 minus 2, or x cubed. Here, similar sort of a problem here. We're going to do the subtraction. We're going to subtract the exponents there because we've got two powers and the bases are the same, and the base stays the same. So it's going to be 3 to the m minus n. And even though I don't know what m and n are right at this moment here, I know that the exponent here is going to be the difference between them. And that's why I can move forward and do that. I've watched sometimes where students will get a little bit confused because they don't know what to do because they don't know what those values are. Well, even if you don't, you just write it out. And just with the operation in there, expressing that even though I don't know these, I would subtract them. Here for this one, this is just written vertically here. So I know that with the division here, I'm going to subtract the exponents. So 12 minus 3. And so we're going to get x to the 9. And then here we've got x to the 4 over x to the negative 2. And again, you just got to be careful when you're subtracting because of that negative there. Subtracting the negative becomes that addition. So this will become x to the 6. You just want to be wary of that. Now, notice in all these cases here, when we do this, that we're doing this subtraction kind of in the numerator. So for example, it's a lot clearer in these last two here. I've got x to the 12 divided by x cubed. It's like x to the 12 minus 3 over 1, x to the 9 over 1. X to the 4 over x to the negative 2 becomes x to the 4 minus 2 over 1. Like it's still in the numerator. Okay, so we're letting that first term, that term in the that factor in the numerator, kind of determine where the work is going to occur here. All right, this next law is the power law. Okay, so it's basically says a power of a power. When I've got x to the m and I take it to another power there, I simply find the product of those two exponents there. Now, another variation of this is to say I've got two, like for example, it's 2mn all to the x here. When I've got an exponent on a product, I can distribute the exponent. And down here, when I've got an exponent that's acting on a quotient, again, I can distribute the exponent. Okay, so exponentiation, the exponents, okay, exponents distribute over multiplication and division. Now, this rule here sort of leads to a problem. So we know that when we've got a power of a power, we multiply exponents. And then we know that when we've got these products and these quotients in there, that the exponent distributes here. Where this leads to a problem is when people think that it does this. If you've got, let's say, a plus b to the x, and people think that that's a to the x plus b to the x, that the exponent also distributes over addition. And that's not true. Okay, like if I've got a plus b, and we'll just pick a different one here, an easy one, squared here. This is not a squared plus b squared. Okay, this is a plus b multiplied by a plus b. And then I have to distribute both of those terms in the first binomial to both of the terms in the second binomial. And so that gets me a squared plus ab. And then I distribute the b, so plus ba plus b squared. It's a little bit more complicated. So although what we're seeing here, this power law is an important rule, this is a rule that frequently gets misapplied just in the wrong spot there. So just want you to make sure you're aware of that. But now let's take a look at some of these examples. I've got x cubed squared. So that is simply going to be the product of those two. So it's going to be x to the 6th. Okay. Here, I've got mn to the 4th to the 5th. So I've got a product inside there. So what's going to happen here is that that exponent of 5 is going to distribute to both of those factors there. And then this will become m to the 5th multiplied by, and now I've got power of a power, so n to the 20th. This next one is going to be identical. It's the same thing. So this will be 3 squared, and then it's going to be z to the 6th squared. Now, in this particular case, though, I know what 3 squared is. I can write that down. It's going to be 9. Z, and then I multiply those two exponents together to get 12. And then this one right here, again, the exponent here, that overall exponent, the cube there, is going to distribute to all these terms here. So it's going to be r squared cubed over 2 cubed t to the 5th cubed. When a question like this pops up frequently on exams, what happens is the mistake that gets made is oftentimes students will recognize that that cube distributes to the power, but they won't put it on the coefficient. They'll forget that it distributes to the coefficient as well. And I've seen all sorts of students that would answer a question like this, everything correct, but the 2 would have remained a 2. Okay, and that's a bit of an issue there because that has to be 2 cubed. So in the numerator, this is r squared cubed is going to be r to the 6th. 2 cubed in the denominator is 8. And t to the 5th cubed is going to be t to the 15th. Now we're going to take a look at the zero law. And basically, zero law says anything to the power of 0 is going to be equal to 1. Now, a little caveat to that. Oops. Well, I forgot to switch pens there. 0 to the 0 is typically for us going to be undefined. Now, it turns out that that expression, it kind of depends on what branch of mathematics apparently that you're working with. I don't work a lot with some of those other ones here, but I've heard recently that, yeah, kind of depends on what branch of mathematics you're working in, how they define that. But for the most part, where we're headed with this course here, we're going to treat that as undefined. But that's the only thing here. Other than that, raising something to the exponent of 0 is going to get you 1. So, as an example here, 5 to the 0 is 1. Negative 5 to the 0 is 1. Now, but watch this. If I do negative 5 to the 0, the 0 only affects the thing that's immediately in front of it. And so basically what we want to interpret this as, this is like negative 1 multiplied by 5 to the 0. So that power of 0 only affects the 5. And so this becomes negative 1 times 1 or negative 1. Okay? The answer there would be negative 1 in that case. Just like over here, I've got a negative 2 multiplied by a to the 0. Now, that exponent only applies to the a. And so this becomes negative 2 multiplied by 1, or just negative 2. Now, in this last one, though, because of the parentheses around that whole base here, well, this one here, this one is going to go to 1 anyway. Okay, that whole thing is the base to the power of 0 is just going to be 1. This is assuming, though, that their variables here aren't equal to 0, that there's no zeros in the base there. Okay, hope that makes sense. Okay, now negative exponents. So when you've got a negative in the exponent here, what that causes is it's like a reciprocal in the base. Or in these examples that we're using right here, a to the negative 1, what it's going to do is it's going to move that term to the other side of the rational expression that it's in. So this is like a to the negative 1 over 1. If I can write that with a positive exponent, if I make it 1 over a to the 1. Or likewise, 1 over b to the negative 1 becomes b to the 1 over 1. It just switches the part of the rational that you're on here. Likewise, if you've got, for example, a over b to, let's say, the negative 2, okay, what happens here is that negative reciprocates the base. So this becomes b over a all squared. Okay, that's what the negative does. The negative does not make the term negative. The negative in the exponent does not change the sign of the term. It changes the position of the power. Okay, so we'll just write that out here. The negative in the exponent, okay, changes the position of the power not the sign of the term. And so here we go. So in this first example here, we've got 2/3 to the negative 4 here. Well, first of all, let's do this in steps here. Let's apply the negative first, and that gets us 3 over 2 to the 4. And then just like in the previous step there, we can distribute that 4 because it's just a quotient. We can distribute that 4 to both parts of the quotient there. And then we get 3 to the 4 is 81. 2 to the 4 is 16. Here, what's going to happen is that we over the fraction here, the m to the negative 3. Actually, I shouldn't say it like this. What we should do here is we should do the division here. Okay, I've got m to the negative 3 divided by m to the negative 2. So I'm going to subtract the exponents. So m to the negative 3 minus negative 2 is going to be m to the negative 1. And then that becomes 1 over m to the 1. Okay, I should still be using those same rules from before here. Just like in this case right here, and again, that negative 2 has really nothing to do with it. But I've got a division here, x to the negative 3 divided by x squared. So this is going to be x to the negative 3 minus 2. So negative 2, x to the negative 5. That negative 5 is only an exponent on the x, so this becomes negative 2 over x to the positive 5. Notice that the sign, okay, that negative sign there never went away, never got affected by that exponent. And then finally, this last one here, that what I'm going to do here first is what's inside the brackets. And I'm going to move that y, the negative 3 up. So this is going to become x squared, y cubed, all cubed. And then that's x squared cubed, y cubed cubed. And so x to the 6th, y to the 9. And the last rule we're going to look at here deals with fractional exponents. So if you've got x to the 1 over m, remember that that is the same as the mth root of x to the 1 here, okay? So the denominator, like it says right here, the denominator becomes the root index. So just like it says down here, if you've got x to the m over n, now there's two ways to do this. You could think of this as the nth root. Okay, the denominator becomes the kind of root, nth root of x to the m, so x to the power of m, and you can consider that inside that radical first. So you would evaluate x to the m first and then the nth root. Or you can actually do this in a different order here where you take the nth root of x and then to the power of m. And the reason why this works here is because order does not matter for multiplication. So what I can do is, for example, x to the m over n. I can see this, for example, I can visualize this as x to the 1 over n to the m, or x to the m to the 1 over n. And because when I have a power of a power, I multiply the exponents together, it really doesn't matter what order I do that in, whether I do the root first and then the power, or the power first and then the root here. Now, just a word of advice, though. Practically speaking, can be quite difficult to take the power first and then take the root, because that power, that exponent in there, makes that radicand really big first, and it can be hard to work with those big numbers here. It's a little bit easier to make the number smaller, to take the root first and then do the power. Anyway, let's take a look at some examples. Here. So 25 to the 1/2 means the square root of 25. And we know that that's just going to be 5. Here, this is 36 cubed, to the 3 over 2. So this means the square root of 36. Now, I could cube 36 and then take the square root. I could totally do that, but I do not know off the top of my head what 36 cubed is. Or I can take the square root of 36 and then cube the final answer. Now, the square root of 36 is 6. And actually, it's not that hard to cube 6. I get 216. Okay? So there's my value there. And again, it's easier to take the root first and then apply the exponent here. So in this case right here, with a base of a, I'm not going to be able to get very far. But I know that this is going to be the cube root of a squared, or it's going to be equal to the cube root of a squared. Either one of those is good. For question 4 here, notice again that I've got a power, but I've got a coefficient here. The -3 is not part of that. So the -3 is going to kind of sit by itself there. Now, the negative in the exponent is going to move that x to the 1/5 into the denominator. So I'm just going to do this in pieces here. It's going to move it into the denominator. And then I'm going to write the 5th root. Whoops. Sorry, I don't know why I wanted to write the cube root. It's going to be, it is going to be the 5th root of x. Okay. Now, that is not typically where that would end. Okay. You've probably talked about rationalizing and to be dealing with those radicals in the denominator here. I'm just going to leave it for right now. We'll talk about rationalizing later. Okay. This one right here, 4x cubed to the 1/2. Now notice all of that is inside the square root. Okay, so actually, there's 2 ways I'm going to do this. I'm going to take a look at this in a slightly different way than I was intending here. I'm going to distribute that 1/2 first. So I'm going to make this 4 to the 1/2, and then x cubed to the 1/2. I didn't have to do it this way. I could have basically put everything under a square root here, but I think this is going to help simplify things a little bit, because this is now the square root of 4. And this will be the square root of x cubed. See, and when I do it like this, I think it's a lot easier to see. Well, the square root of 4 is 2, and it's still multiplied by the square root of x cubed. Okay? Now, that can actually be simplified a little bit further because think of it like this. This is 2 multiplied by the square root. This is x multiplied by x multiplied by x. What a square root does is it takes a pair of factors and produces a single value. Just like when we say, for example, the square root of 9 is equal to 3, that's because 9 is 3 times 3, and the square root symbol simply produces a single 3. So here, this is going to be similar to, for example, the square root of x squared multiplied by the square root of x, and that's simply going to be x. The square root of x squared will simply be x. Now, at this point in time, maybe that's not necessary. Maybe this is as far as we need to go. It's just that that's another possibility here. Similar to that right here, again, I can take that to the 1/2 and distribute that through to the 3 factors. 16 to the 1/2, that's going to be the square root of 16. Here, for this moment right now, it might be smart for me to simply look at this as x to the 4th to the 1/2 as a product of their powers. 4 times 1/2 is simply going to be 2, and this becomes the square root of y. And then the square root of 16 is 4. It's just x squared root y. And then I'm done. Okay, so in this particular problem here, or this particular set of problems, all we're going to do is simplify, but we are going to leave all of our answers with positive exponents. Okay, now that isn't necessarily a rule per se when it comes to simplifying, but it is something that you'll find that people will frequently do. They'll try to leave things with positive exponents. Okay, so here we go. So let's just take a look at A here. Now, anytime you've got that division bar there, remember that implies a set of brackets here. So let's split this up here. Okay, so in the numerator, let's do that multiplication first. So I'm going to add the exponents together. So I'm going to get b to the 5th plus b to the 5th times b, which will be b to the 5 plus 1, or 6, all over b squared. And now I'll do the division there, and that's going to be subtraction. It'll be b to the 6 minus 2, or b to the 4. Okay, let's take a look at this next one here. And again, what I probably want to do here is again, utilize or make use of the fact that there's an implied set of brackets there. So look at the denominator first, okay? And I see y squared cubed, so I know that when I multiply those exponents together, this will be y to the 6th. And then I've got 1 7th divided by y to the 6th, so I subtract the exponents, and I get y to the 7 minus 6, which is just 1, or just y. Okay, this one right here, I'm going to do the exponents first, the powers of the powers, before I do the multiplication that's implied by that juxtaposition there. So I've got b squared cubed, which is going to be b to the 2 times 3, or b to the 6. Okay, and then maybe I'll put that in parentheses there. Actually, I'll clean that up just a little bit there. Whoops, sorry, I'm going to clean that up because it's a little bit too close, what I have written there. Okay, so this will be equal to b to the 2 times 3, okay, or b to the 6, and then this will be multiplied by b to the 4 times 4, okay, which is going to be 16. So this is going to be b to the 6 multiplied by b to the 16, and then when I multiply those two powers together, I'm going to add the exponents, and 6 plus 16 is 22. So the answer here is going to be b to the 22. Here, what's going to happen is, because of all the multiplication within the set of brackets in the base of that power, that square is going to distribute to every factor. Okay, so 3 squared multiplied by x to the 6th squared multiplied by y to the 5th squared. And so 3 squared is 9. Then I've got a power of a power, so I multiply the exponents, so x to the 12. Y to the 5th squared, I'm going to multiply the exponents, and I get y to the 10. over here, this is just straight out multiplication. So, and because everything's multiplied together, this actually makes it pretty straightforward here. So -3 times -4, I'm going to take the coefficients separately. That'll be positive 12. And then I've got m squared multiplied by m to the 4th. So that's going to be m to the 6th. And then I've got n multiplied by n to the -2 here. Remember, I add exponents together. So this is like n to the 1. So the product here will be n to the, well, what's 1 plus -2? Well, it'll be -1. And because I want this as with positive exponents here, what I've got to do is move that n down into the denominator. So it becomes n to the positive 1 down in the denominator. But remember, I don't have to write the 1 there if it's just a 1. That's implied. So there we go. So 12m to the 6th divided by n. In this next one here, again, I'm going to do what's inside the brackets here first. So I'm going to, that implied set of brackets. So this will be b to the 5th multiplied by b to the -1. Add exponents together, and 5 plus -1 is going to be 4. And then I'm going to perform the division there by subtracting the exponents. This will be b to the 4 minus -3. So that will be b to the 7. I've got a positive exponent, so I'm good. That's as far as I wanted to go here. Okay, let's keep going. Now, when I get an expression like g, and I see that kind of a big set of parentheses there, I want to simplify what's inside that first. Now, before I apply the square. Now, there's really not that much I can do with the 5 and the 4. Okay, that's just not a fraction that I can simplify. But I've got an m over an m squared. So I'm dividing powers. So what that's going to do is I'm going to subtract the exponent. So this will be m to the 1 minus 2, or m to the -1. And then I'm going to get n cubed over n. So n to the 3 minus 1. So n squared. Now, I'm going to simplify that, or really, it's not really simplifying so much as I'm going to move the m down so that I don't have a term there, or a factor with a negative exponent. And now everything here gets squared. Okay, so that 2, this 2 right here, I'm going to color it in blue. That 2 right there gets distributed to every factor here. So it'll become 5 squared, which is 25. N squared squared will be n to the 4th. 4 squared is 16. And then it's m to the 1 squared. It'll just be m squared. So that becomes 25 n to the 4 over 16 m squared. Okay, for this next one, you know what? I'm going to put together that denominator first. I'm not even going to worry about the numerator for right now. So in the denominator, and there's some layers to this. First thing I need to deal with is that bracket, sorry, that square on that bracket here. So I got to distribute that first. So I'm going to get 3 squared, which will be 9, m squared, squared, n to the 4th squared. So n to the 4th squared is going to be n to the 8th. And that is still multiplied by m to the 5. Whoops. Oh, shoot. I wanted to write m all over again. That's going to be m to the 5 n squared. So now, again, I'm still dealing with the parentheses around the denominator. So this is going to be my numerator. Still haven't done anything with that. N cubed, n to the -2 over. Okay, well, there is no other coefficient other than 9. So 9, m to the, well, when I multiply the 2 powers of m together, I'm going to add the exponents. So 2 plus 5 is 7. N to the, well, I'm going to multiply those 2 powers of n together, add the exponents, and I get n to the 10. And remember, I can do that because order doesn't matter with multiplication. So I can move the powers of m and the powers of n around and put them together. Now, I'm going to do the division. I'm going to perform the division here. So there's nothing to do with the coefficient. It's still going to be over 9. There's nothing that's going to move that 9. It's going to stay down there. But I'm going to get m cubed over m to the 7th. So I'm going to subtract the exponents, and it'll be m to the, well, 3 minus 7 is -4. And then I'm going to get n to the negative 2 over n to the 10. So it's going to be n to the negative 2 minus 10. Well, it's going to be n to the negative 12. And then finally, and I'll just go over here, I'm going to convert those into positive exponents, but that actually moves them all down. Okay, so that 9, nothing happened to the 9. Nothing could move the 9. But it'll be m to the positive 4 in the denominator, n to the positive 12 in the denominator. So what's left in the numerator if everything comes down? And the answer is 1. Okay, so there we go. That's what that reduces down to. 1 over 9 m to the 4th and 12 to the 12th. For this one right here, okay, normally what I would do is deal with this, what's inside that set of parentheses right there that I just highlighted. But there's nothing really that I can do there. The negative 2 over 3, that is about as nice as that's going to get. And then I've got two powers there. I've got x squared and y, but there's no common base. So there's really nothing I can do. So what I'm going to do is apply that exponent on the whole thing, the negative 3. But I'm going to do it in pieces. I'm going to apply the negative first because I know that the negative is going to simply flip the base. Now, you might notice at this point here that I didn't write that negative, this negative right here in. And that's because when you just look at it right now, it looks like it would move to the denominator with that 2. And in actuality, yeah, it does. It does. But you can actually put that negative kind of wherever you want here because multiplying by a negative, dividing by a negative, whatever, it's the same thing. It just looks better if it's in the numerator. I have a little bit of freedom to put that negative kind of wherever I want. And so that's where I'm going to leave that. And now I'm going to apply the cube. So this becomes negative 3 cubed. Okay, and I could have done that separately. I could have done that as negative 1 cubed times 3 cubed, but this is just as easy. And then y cubed, 2 cubed, and then x squared cubed. So in my numerator, I'm going to get negative 27 y cubed. That's as nice as that's going to get. 2 cubed is 8. X squared cubed, it's a power of a power, so I'm going to multiply these exponents to get x to the 6th. Okay, and there we go. Let's keep going. Next one here, J. Okay, well, like we've done before here, I think what I'm going to do here is I'm going to do the numerator and the denominator here separately. I'm going to simplify those. Okay, and what I'm going to do is I'm going to distribute that negative 2 across all those terms there. So 4 to the negative 2. Now this is going to be y squared to the negative 2. So when I do that, I'm going to multiply the exponents. So y to the negative 4, z to the negative 2 over, and here I'm going to distribute the negative 5. So y to the, well, y squared to the negative 5 will be y to the negative 10, z to the negative 5. Okay. So I've dealt with the numerator and kind of the denominator separately. Now I'm going to deal with this division. I have got 4 to the negative 2. Well, there's nothing else going on there. The negative is going to put that 4 squared in the denominator, and 4 squared is 16. Then I'm going to deal with the powers here a little bit differently. Y to the negative 4 over y to the negative 10 is going to be y to the negative 4 minus negative 10. Okay. And then I'm going to get up here in the numerator, z to the negative 2 divided by z to the negative 5 is going to be z to the negative 2 minus negative 5. And I'm going to pay very close attention to the fact that I'm subtracting a negative. So when I say y to the negative 4 minus negative 10, that's going to be negative 4 plus 10, or y to the 6th. Z will be negative 2 minus negative 5, or z cubed. Okay. Next. All right. Well, again, what I'm seeing here is I'm seeing some multiplication, but I've got a power over that parenthesis there. So I'm going to deal with that first. And because everything's multiplied together in the base here, this is going to be 2 cubed multiplied by x to the, and that's going to end up being negative 6 because I'm going to do that power of a power. And then I'm still multiplying by 4x squared. Okay, well now if I multiply the coefficients together, 2 cubed is 8, multiplied by 4 is going to give me 32. And then when I multiply the powers of x together, I'm just going to add the exponents. So negative 6 plus 2 will be negative 4. And now remember how this works. That negative 4 is only an exponent on the x. So it's only going to affect that x there. So this becomes 32 over x to the positive 4. The 32 does not move. If it looked like this, it would have moved. Okay, it would have moved, but that's not what it looked like, right? Those blue parentheses weren't there. So that negative 4 in the exponent does not apply to the 32. Okay, this next one, again, I'm going to play with the numerator and denominator separately. So what I've got here, first of all, is 9 to the negative 2. Okay, x to the 5th to the negative 2 is going to be x to the negative 10. Y cubed to the negative 2 will be y to the negative 6. I'm just going to multiply the exponents together because I've got powers of a power, or a power of powers, I should say. And then in the denominator, well, there's really not much for me to do to put those together. That is as good as it's going to get. Now, here we go. 9 to the negative 2. The negative is going to cause a reciprocal, so I'm going to have 9 squared in the denominator, and 9 squared is 81. Then in the numerator, I'm going to get x to the negative 10 minus 4. That's what that division is going to look like. I'm going to subtract the exponents. For the y's, I'm going to get y to the negative 6 minus negative 6. And actually, there's something that I could be said about that in just a moment, but I'll get there in just a moment. Now I'm going to get, okay, it's still over 81. Nothing changed there, but this is going to end up being x to the negative 14. And then notice that negative 6 minus negative 6 is actually equal to 0. Okay, so that becomes y to the 0. And actually, and we know that y to the 0 is just going to be 1. Actually, what could have happened here, up here, I could have just canceled those two terms. They were exactly the same. Those two factors are exactly the same. I could have dealt with that earlier here, but that's okay. It's sometimes useful to see that happen when you're working through a problem. But anyway, that y to the 0 becomes 1. I've got 81 in the denominator, and I've got that x to the negative 14 in the numerator, which is going to push that down into the denominator. And once again, I'm left with that question. Well, okay, what's left in the numerator? And the answer is 1. Okay, now we're almost done. So here, like we've done before here, what I want to do here is I want to simplify what's going on within the parentheses here before I apply the cube. So I look at the negative 2 over the 3, and there's really nothing I can do about that. It's still going to just say negative 2 over 3. But I've got x to the 1 over x to the negative 3. So it's going to be x to the 1 minus negative 3. Ooh, and I am going to run out of room here real fast. Hold on. Okay, so I've got x to the 1 minus negative 3. And then here, I'm going to get b to the negative 2 minus 2. And this is still all cubed. So applying that, this is going to be negative 2 over 3. Nothing happened there. X to the, well, 1 minus negative 3 is going to be x to the 4. B to the negative 2 minus 2 is going to be b to the negative 4. Now, that, I'm going to move this up just a little bit here. That is going to move that b down. The x to the 4 is not going to go anywhere, but that b to the negative 4 is going to become 1 over b to the 4. Now I can distribute that cube to every term here. So I'm going to get negative 2 cubed will be negative 8. Okay, x to the 4 cubed is a power of a power, so x to the 12. 3 cubed is going to be 27. And b to the 4 cubed is going to be b to the 12. And so there you go. For this one right here, notice that within the parentheses, I don't have any kind of factors that have a similar base that I can put together. Okay, I could move the m to the negative 3, like I could move the m down, I could move the p down into a denominator here. But you know what? For the time being, I'm just going to simply distribute that exponent through. I've got a whole bunch of factors there. I'm going to distribute the exponent through. So this will be negative 4 to the negative 3, m to the, okay, well, I've got a negative 3 to the, m to the negative 3 to the negative 3. I'm going to multiply those together. That's going to be positive 9. Well, that's nice because that means that won't move. That's the exponent is now positive. Here I'm going to be left with n to the n squared to the negative 3 will be n to the negative 6. Okay, that one's going to move in a second here. And then p to the negative 1 to the negative 3 will be p to the positive 3. And that one won't move, which is kind of nice. So now I've got a negative exponent on the coefficient. I've got a negative exponent on the n. So those are going to move. Negative 4 cubed will be negative 64. I'm going to put the negative up top. The negative cubed, the negative's not going to go anywhere. I'm going to move it up to the top there. M to the 9 p cubed. And then that n to the negative 6 can be written as n to the 6th in the denominator. I just move it to the other side of the rational there. And there you go. And now finally, this guy right here, there are a few different ways that this one can be handled. So first of all, I'm going to do it like this. I'm going to show you something a little bit lazy here. When I see something like this, okay, now I'm going to take a bit of a shortcut right at the end here. I've got 25 and 12 in the numerator, 9 and 10 in the denominator. So 25 and 10 both share a common factor of 5. And if I cancel that out here, if I divide that out, I'm still left with a factor of 5 here and a factor of 2 here. 9 and 12 both have a common factor of 3, so there's going to be a 3 left over here and a 4 here. And then, next layer up here, 4 divided by that 2 is going to give me 2. So putting those coefficients together here, in the numerator, I'm going to have 5 times 2, which will just be 10, and in the denominator will be 3 times, well, 1. Okay, when you do that division, you get a 1 there. So 3 times 1 is just going to be 3. Now, look at the a here. I've got a to the 4th in the numerator. And just you got to remember how multiplication with fractions work. When you multiply a over b multiplied by c over d, the answer is ac over bd. You just multiply straight across here. So really what I've got here is I can actually just extend that line all the way across. Everything in the numerator is multiplied together. Everything in the denominator is multiplied by itself there all together. So I've got an a to the 4th divided by a squared. That's simply going to be an a squared in the numerator. A to the 4 minus 2. In the numerator, I've got c to the 5th, and then I've got a c in the denominator. So c to the 5 minus 1. So c to the 4. Oh my gosh, I can't believe I missed b. I didn't even see the b there in the numerator. So what I've got in the numerator, I've got b to the 1 over a b squared in the denominator. So b to the 1 minus 2 is going to be b to the negative 1. And so to finish this up here, I'm going to get 10a squared c to the 4th over 3b. Okay. Now, I'm going to let you know right now before I kind of wrap this up here that in several of these questions, I did not choose the quickest method to the answer. I chose a more systematic approach to it. And I did that on purpose because if this is kind of something that's new to you and working this thing through is something new to you, then you're going to want to have a systematic approach. Particularly, you want to follow the order of operations, okay? But the more comfortable you get with this, the faster it's going to get. The easier it's going to be for you to anticipate where this is going to go and to take some shortcuts. Okay, so don't worry about that right now. Just get good at it. Practice this, and the more practice you get, the more comfortable you get, and the easier these kind of questions will be.